Good morning, students. So in the last class, we had completed the induction furnace.
Hello. Hey.
Who is? So in this class, we will learn about what is meant by gating system, and how it is to be get arranged in a sand casting or any other casting process. So what are the different types of gates are there, and what are the multi gates are to be get used, and how the sprue area and how the gate area, what is the dimensions of the gate and everything. So that is to be get explained in this class. So we'll start the class with a gating system. So in the last class, we had completed the furnaces. So which is nothing but a cupola furnace, induction furnace, and electric arc furnace. So in the next class, we will complete about the crucible furnace. So in this class, we will learn about the gating system, how it is to be get arranged. So because the gating system is the one of the very important thing, so that the fluidity which is to be get carried over to the sand casting, it must be in a correct manner. If the gating system is not in a correct manner, a number of casting defects will be get erased. So to decrease the casting defects, the gating system should be arranged in a correct way. So at what place the gating system is to be get arranged, and how it is to be get arranged, and what are the casting defects are to be get occurred due to the due to the improper gating system. Due to improper gating system, what is going to be happening there? Clear? So we'll see the first slide. So when you students working in a laboratory, foundry laboratory, so used to place a gating, a small gates, so that the molten metal which is to be get poured through the sprue, it can be get flow a good flow over to the gates part. So you will be just play how to place the gating systems in that sand casting. Some people will place a very more diameter, some people will place a very less diameter. So what is the difference when you are placing a very less diameter and very more diameter? So one of the main defect is when the correct flow molten metal is not flowed into the pattern, what will happen? The solidification cannot be get complete. So to get the solidification to be get complete, a limited quantity is to be get flowed into the mold cavity. So what is the limited quantity is to be get required, and how much the ratio the gating system is to be get placed. So at what place this is to be get arranged. So what is the area of this one, and what is the defects we are going to be getting from this one. Okay, the contents are: the first thing is introduction, the second is elements of the gating system, the third is the functions of gating system, and the fourth, defects occurring due to the improper design of the gating system, and the fifth, types of gates, pouring time, gating ratio, guidelines for the designing gating system, review of the papers, conclusion, and the reference. So these are the topics which are to be get covered in this class. Clear? So we'll start from the introduction. So what is meant by gates? So introduction, you know already what is meant by a gating system and how it is to be get arranged. So the mould is used for producing a casting. So the molten metal is conveyed into the mould cavity by using the gating system. By using the gating system only, the molten metal is to be get flowed over to the mold piece. Over to the mold piece. So without having a gating system, only a sprue and a runner is there. We can't flow the molten metal over to the mold piece. So something connection must be there between a sprue and as well as the mold. So for that sake, we are going to be interconnected the sprue and the mold cavity with the help of a gate. So in the casting process, gating system plays an important role to produce a high quality casting. And so in a casting process, gating system is very, very important. So it is a very important role. It plays a very, very important role so that when a limited quantity, whatever the quantity required by the mold is to be get poured. If it is not to be get poured into the gates, what is going to happen? The different defects like a misruns, hole shuts or oxidation of the metals or porosity, holes, cracks. So this type of casting defects will be get appear. Right. So the next one is a poorly designed gating system results in a casting defects. A poorly designed gating system results in a casting defects. So right students, the third point, a poorly designed gating system results in a casting defects. As I had told you, what are the different casting defects are to be get occurred when a purely designed gating system is to be get arranged. So a gating system controls mold filling process. The main function of a gating system is to lead molten metal from a ladle to the casting cavity, ensuring smooth, uniform, and complete filling. So how the gating system is to be get filled when the molten metal is to be get completed from the furnace and it is to be carried over with the ladles, and from the ladles it is to be get poured over the sprue, and the sprue will be having a certain diameter and it is having a connection to a gates. So the molten metal is to be get poured slowly towards the mold path. So when the gates are not having a very smooth, what is going to be happen? The molten metal will be get stick on over to the gatings only. Now the molten metal, it cannot be flowed smoothly over to the mold cavity. Clear? Next point. So this is the elements of the gating system. So you know what is the diagram of the gating system. So the diagram is the casting piece. So in gates, these are the three different gates are going to be get happen. So this is the pouring cup and this is the sprue. So here the gating system is, it is not a single gate. It is having a three gates, multi-gate system. It is a multi-gate system. So here it is nothing but a sprue. It is a sprue base. So from this sprue base, a runner is to be get connected. From this runner, the sprue, from the sprue, the molten metal is to be get carried over. So for each and every instant point, a gate is to be get arranged so that the molten metal is to be get moved towards the gate and goes over to the casting place. Similarly, 1, 2, 3. So these are the ingates which are going to be known as, it is named as a ingate. Clear? So the elements of a gating system are pouring cup, sprue, sprue well, cross gate or a runner, ingate or a gates. So what is the definition of each and every elements? Clear? So the pouring cup, we will learn about the first one is pouring cup. So it is a funnel shaped opening made at the top of the mold. The main purpose of the pouring basin is to direct the flow of the molten metal from the ladle to the sprue. It is a funnel shaped opening made at the top of the mold. So you had seen here, it is like a funnel shape. So it is used to pour the molten metal from this one. So from the pouring cup, it moves carry over to the sprue part. So more from the ladle to the sprue. And the next name is sprue. Next element is sprue. It is a vertical passage connects the pouring basin to the runner or an ingate. So it is a generally made tapered downward to avoid the aspiration of air. So the cross section, so cross section of the sprue may be square, rectangle or a circular. So the cross section of this one. So this is the cross section. It may be square, rectangle, or the circular. When you see the shape, so this is to be shaped in a tapered downward form, because so that if it is having some inclined shape, so that the molten metal can be easily flowed over to the sprue base to the ingots. So if it is not having any inclined shape, what it is going to happen, the molten metal will be get stick on into the sprue base only. It cannot be get moves over to the gating systems, right? So the next one, sprue well. It is located at the base of the sprue. It arrests the free fall of the molten metal through the sprue and turns it by a right angle towards the runner. So it is a tapper. So this is a sprue base which is going to be used to, it is nothing but a basin where the molten metal is collected. So from that it is to be get forward over to the ingots. Next, the runner. So it is a long horizontal channel which carries the molten metal and distribute it to the ingots. So it will ensure proper supply of the molten metal to the cavity so that the proper filling of the cavity takes place. So the runner is a uniform. It is a uniform shape. It is used to distribute the molten metal uniformly to each and every ingate system, so that the molten metal is to be flowed in a correct manner. If the runner is not uniform, what will be happen? In one gate it will be getting a more amount of a molten metal, and in other gates it will be getting a less amount of a molten metal. So this runner is a very uniform part from which the gating system is to be carried over a molten metal uniformly. So it is a long horizontal channel which carries the molten metal and distribute it to the ingots. So it will ensure the proper supply of the molten metal to the cavity so that the proper filling of the cavity takes place. So next one is gates. So these are the small channels connecting the mold cavity and the runner. So the gates used may vary in number, depends on the size of the casting. It depends on the size of the casting. If the size of the casting is very big, so what it happens, it will take more number of ingots. It will carry more number of ingots. If the casting is very small, it will take one or two ingots. So depends on the casting molding part, the ingots are to be get arranged. So the gates, these are the small channels connected to the mold cavity and the runner. The gates used may vary in number, depends on size of the casting. And one more thing, students, the gate systems will be having a very small diameter. It won't be having a very large diameter, because the molten metal is to be get poured very smoothly. If it is having a very large diameter, what it happens, some air is to be get inside of the molten metal. So due to the air and oxidization, what it occurs one type of defect on a workpiece. So the gate system is also having a very small diameter, not a very large diameter, not a very small diameter. It is having a very medium part, the outlet. The next one is combination of cooling system. So we had seen earlier what is the different part, what is the diagram. So what is function of the gating system? So good gating system should help easy and complete filling of the mold cavity. So it should fill the mold cavity with the molten metal with least amount of a turbulence. So with the least amount of turbulence, it should be get filled the mold cavity with the molten metal, right? So it should prevent a mold erosion. It should prevent a mold erosion. It cannot be get any cracks or any other thing. So it should establish a proper temperature gradient in the casting. So whenever after completion of the molten metal, it is to be directly carried over to the sprue. So if it is taking some time, what will be happens? It takes time from flowing over to the sprue to the gates, so that the temperature will gradually decreases. So when the gates towards the casting, automatically the temperature decreases. So there will be some defects while doing a solidification. So whatever the temperature you are going to maintaining when the completion of your molten metal, it's better to maintain the same temperature. So so that after it is carrying over to the mold cavity, if the temperature is to be get decreased, it's okay, so that we can decrease the defects also. So it should promote directional solidification. So it should promote the directional solidification. You know what is meant by solidification, right? So it should regulate the rate of flow of metal in the mold cavity. So it should regulate what is the rate of flow of the metal in the mold cavity. quantity. So from each and every ingate, how much amount it is to be get flowing. So the next one is defects occurring due to the improper design of a gating system. So what are the different defects which are going to get occurred? So when it is not having a correct gating system. So I had told you, when the gating system is not having a very smooth, it is having some rough surface, it is having some irregular surface, how the molten metal can be get forward over to the mold cavity. So the gates must be a very smooth. So when it is having improper design, what are the different defects are to be getting? So when more defects are going to be occurred, what happens to the strength of your workpiece? It is to be get decreased. The life of the workpiece just decreases. The strength will be get decreased. So a number of defects are to be get occurred. A cracks, pores, or a holes, or any other thing. So what are the different defects are to be get occurred? So the first one is oxidation of the metal. So oxidation of the metal means, after, if it is not having a correct flow, after solidification, some type of white layer is to be get produced over to the workpiece. White layer is to be get produced over to the workpiece. So mainly the oxidation of the metal explains that here, sir, the molten metal is to be get mixing with the mold part. When it is having, when it is not having a good reaction, what it happens, some oxygen is to be get present. Okay, so the metal oxidation takes place when an ionic chemical reaction occurs. So I had told you, when some reaction is to be get occurring, so when the molten metal is to be get poured into the mold cavity, so there it can be having some reaction takes place. So when those type of reaction occurs, some oxygen is to be get present. So oxidation is in the form of a metal corrosion. So it comes under the corrosion part, corrosion defective. So the next one is cold shut. A cold shut is a discontinuity that appears on the surface of the cast metal as a result of two streams of a liquid meeting and failing to unite. So a cold shut is a fault in the surface of the piece of the metal caused by the two streams of the molten metal not joining properly when the piece is being cast. So when the solidification is not completed perfectly, and the solidification is not perfectly done, so what it happens, the workpiece can be get break. So workpiece is going to be having a very less strength. It is having some cracks. So when the two pieces cannot be get joined, so it is one of the very most important defective it is going to happen. So it occurs only when it is having a very less amount of molten metal is to be get carried over to the gates. So when it is not having a continuous molten metal over to the gates, so there it explains that the solidification cannot be get done purely. So when the solidification is not done correctly due to improper molten metal, so due to less amount of the molten metal is to be get carried over. So the cold shut is explains that it is a discontinuity that appears on the surface of the cast metal as a result of two streams of the liquid meeting and the failing to unite. So unite means the solidification cannot be get done. So the all the bonds is not having a good connection. So a cold shut is a fault in the surface of the piece of the metal caused by the two streams of the molten metal not joining properly when the piece is being cast. Right. So the mold erosion. The third effect is mold erosion is a wearing away of the mold as a liquid metal fills the mold. So this type of defect usually occurs in a sand casting because most of other casting process have more robust molds. So in a sand casting only we can see this type of mold erosion. We can't see this type of mold erosion in permanent molding. We can't see in investment casting. So we can't see the centrifugal casting. So we will see mostly occurs in a mold erosion occurs in a sand casting only. Clear, because it is totally done with a greens and everything it is done. So we are going to occur this type of thing is in a mold part. So the wearing away of the mold as a liquid metal fills the mold. So this defect, this type of defects usually occurs in a sand castings only, right? So next, shrinkage. So you know the shrinkages. So most of the defects, the other thing, other important point is the defects is to be get reduced means the ramming is to be get done perfectly. The ramming is to be get done perfectly. The coop and a track after placing in a correct manner, it is to be get shake correctly. So that if it is any having a bubbles inside, it can be get bulge. So to do after placing the coop and a track, it is to be get shake in a correct manner. in a correct manner, so that the bubbles cannot be get there. Air which is going to be happen, it is not to be get there, it is to be get removed. So shrinkage defects and causes. So shrinkage occurs because the metals are less dense as a liquid than a solid. It is having a less dense. So a shrinkage cavity is a depression in a casting which occurs due to the solidification process. It is due to the solidification process only the shrinkage casting, the shrinkage defect is to be get occurred. So the next one is porosity. The definition of the porosity is any void or hole in a casting. So porosity can be caused by gas formation or a solidification shrinkage, while the metal is a liquid. So we are going to use the vent holes. Why the vent holes are to be get used? If any gas are there in the total thing, it is to be get removed, it is to be get removed from the vent holes. So after placing the total sand casting, we are putting some vent holes, so that is also used to reduce the defects only, reduce the defects only. If it is not done, what happens, the bonding will be in a correct manner, the defects will be get more, some cracks will be get taken, the molten metal cannot be get flowed in a correct way. So the porosity explains that any holes in the casting, so it is nothing but a hole in a casting, holes part. So misruns. A misrun occurs when the liquid metal does not completely fill the mold cavity. So I had told you. So misruns usually occurs when a proper amount of molten metal is not taken into the gate. When a amount of molten metal is what was taken in a gate and you had stopped giving the supplying the molten metal, what it happens, whatever the molten metal you had supplied inside it, it is not sufficient up to the part. So we had already arranged a runner. So from the runner, we can see what is the excess metal you are going to be getting, which is not having. Clear? So we have to be get flown continuously over to the gates so that they won't be having any number of defects. So that whatever the molten metal is required while during the solidification, it is to be get taken. It is to be get taken. So we will also see that when permanent casting, you had observed in a permanent casting or investment casting or scientific casting, what you had seen, the pressure is to be get applied when the molten metal is to be pouring inside of the mold. So why the pressure is to be applied? When the molten metal is, there is a quantity of a molten metal, requirement of a molten metal, it can be get easily like flowed. When the pressure is not applied, it is to be having a very easiest manner. Where is the molten metal can be get taken over to the mold cavity. So the in that type of casting systems, what we are using, some amount of force is to be get applied over to the molten metal, so that the molten metal cannot be get back, cannot be get reverse. It is to be get flown in the frontward direction only, right? So the Mistron explains that when there is a shortage of a molten metal, this type of defects is to be get occurred. So the next one, so penetration of the liquid metal into the mold walls. So what are the different types of gates? So what is the different types of gates and how it is to be get arranged? So depending upon the orientation of the parting line. So there are two types of gates. One is a horizontal gating system. The second is a vertical gating system. So the next one is depending upon the position of the in gates, horizontal gating system. So it depends on the position where you are going to placing the mold cavity, where you are placing the sprues and everything, the top gating system, the bottom gating system, and parting line gating system. So these are the three gating systems which are to be get placed. So these are the diagrams. The first one is the top gating system, bottom gating system, and parting line system. So the top gating system, as you had seen, here is mold cavity. So the top of the mold cavity, the sprue base, and a gate, runner and a gate. So here it is a gate is used, and from this manner the molten metal is to be get flowed into the part. So the bottom gating system, the gates are totally at the bottom of your mold cavity, the bottom of your mold cavity. So in the third one is parting line gating. So parting line gating is nothing but, you think it is a cope and a track. So it is in between. It is in a between. So it is in the drag part. The gating system will be in the drag part. So most of the things we will do in our college, it is nothing but a parting line gating system. We will do in the parting and gating system only, because we will place in a track when gating part is to be get placed, and over that one the cope is to be get placed. This is the third one which we will follow in the college. So what is the pouring time? So we want to know how much time is going to be taken, how much time is to be get taken while the molten metal is to be get poured. So first pouring rate is nothing but the time taken for filling the mold cavity by a known quantity of metal, that is pouring time, which can be used as an index to determine the pouring rate, which can be used to determine the pouring rate. So the first one, pouring rate is nothing but the time taken. So pouring time, it is nothing but the time taken to fill the mold cavity. So how much time is to be get taken to fill the mold cavity through the gates, right? The next one is when the molten metal is being poured into the mold at a very fast rate, mold erosion, surface excessive shrinkage may take place. So I had told you the molten metal cannot be flowed in a very fast rate. It cannot be done in a very slow rate also. It can be done in a very medium part. It is to be taken place in a medium only. It must not be very fast. It must not be very slow, because if it is very fast, what happens? A high amount of liquid is be getting forcing over to the mold cavity. So due to that one, a many number of defects are shrinkage. So when it is very slow, so it cannot be get done, because whatever the molten metal you had sent into the cavity, it starts some time something of operation. So you are again pouring some molten metal. So very slow is, it is not enough, right? So when the pouring rate is very low, the complete filling of the mold is not assured and result in excessive drop in the molten metal temperature. So I had to, it is very not very slow, and it is very fast. It must not be very fast, and it must not be very slow. If it is taken very fast, what it happens? Mold erosion of surface and excessive shrinkage will be get taken place. When it is very low, what happens? The temperature is gradually get decreases. Whatever the molten metal temperature is to be get taken over, it is gradually decreases, so that the shrinkage cannot be get done. So this results the cold shut and a mistral. So these are the defects. What is going to happen when a very low rate is taken? So in order to avoid this, it is necessary to arrive at the correct rate of pouring of the metal. So if in order to avoid the fast rate and a low rate, it must be a correct rate of the pouring, a medium quantity. So the type of the metal, size and shape. So type of the metal, size and shape the casting beside the pouring rate. So it totally decides what is the type of the mold cavity, what is the size, what is the shape, what is the molten metal. Depends on this one only. The pouring time is to be get decided. Right. The next one is pouring time. Next one is gating ratio. So the gating ratio explains that. So gating ratio explains that it refers to the relation between the area of the choke to the total area of the runner to the total area of the ingate. Right? It is taken into three considerations. It is taking three considerations. One is the choke to the total area of the runner to the total area of the ingates. So it is written in as AC is to AR is to AJ. So AC explains about the choke area, AR explains about the runner area, AG explains that inner gate area. So this is the ratio which is to be get maintained. The gating ratio. And the gating system completely controls the molten metal flow. So the gating systems can be classified as a pressurized system and an unpressurized system. So the gating system completely controls the molten metal. Yes, the total molten metal is totally controlled by gating system only. So gating system are two types. One is a pressurized system and other is an unpressurized system. So gating ratio depends on the nature of the molten metal. So in the last slide, I had told you the gating, the pouring rate is totally depends on what is the type of a mold, what is the type of your size, molten metal is to get poured. So it depends on that one only. The pouring rate is to be get defined. In the same way, the gating ratio depends on the nature of the molten metal. The next one, what is meant by a pressurized system? So the pressurized system is used for reactive metals. When the metals like magnesium alloys, so when the magnesium alloy metals are to be get taken, so this pressurized system is to be get used. Magnesium alloys. So the unpressurized grading system is used for normal metals. When the metals like brass, steel, and aluminium. So when these type of metals are to be get taken, unpressurized gating system is to be get followed. So unpressurized system is used for a normal metals, whereas a pressurized system is used for a reactive metals. So a gating ratio such as 1:2:1 or 1:0.75 is to 0.5 refers to the pressurized system. So this is the ratio it is to be get maintained. So one is the choke area, second runner area, third one is gate area. So one is a choke area, 0.75 is the runner area, 0.5 is a gate area. So depends on this ratio, the pressurized system is to be get used. So whereas the unpressurized gating system, 1:2:2 or 1:3:3 or 1:1:3. So this mostly refers to the unpressurized gating system. So one is the choke area, two runner, and the three is a in gate. The one choke, three is a runner area, and the three is a in gate area. So one is a choke, one is a runner area, and the three is a in gate area. So this is the ratio which is to be get followed for unpressurized, and this is the ratio which is to be get followed by a pressurized. So what is a pressurized? How for what type of thing it is to be get referred? So pressurized system is referred to as a gate control system. It is referred to as a gate control system since in gates controls the flow of the metal. So you can observe here it is 1:2:1. So the one is the choke. What is the choke area from where the you're passing over to the runner? So the two is a runner area. So here you are going to be taking a high amount of the molten metal in a runner. But again, one was taken in a gate area. So one is explains that though you are having a more amount of molten metal in a runner, is very a medium amount of molten metal is to be get carried over to the gate, right, friends? So the molten metal is totally controlled over to the gate system only. Though you are having a more molten metal in runner, but the total molten metal is controlled over to the gate system, right? So the unpressurized system is referred as a choke control system since the choke controls the flow of the molten metal. So in this you can see that one, so one is a choke, the two is a runner, and the two is a ingate. So here it is not controlled by a runner, it is not controlled by gates. Here it is controlled by a inlet force only. At the starting only it is going to get controlled. So what is the starting choke area? In the choke area, by the choke area, the molten metal is to be get controlled. So in a pressurized system, high metal velocity occurs and results in turbulence. So in a pressurized system, the turbulence part is to be get occurred. So in a case of unpressurized system, turbulence is produced and the stream flow is induced. So in a unpressurized, turbulence is to be get occurred and a streamline flow is induced. And next one, pressurized system consumes less metal and yield is more. And yield is more. So unpressurized system consumes more metal. It is consumes more metal and yield is very slightly lowered because you can see in this one 1:2:2. So in this the choke area is controlled, but after the choke area a large amount of the thing is carried over to the runner and the same large amount of the thing is carried over to the gates. So what happens here? A very flow rate is to be get difference. So unpressurized system consumes more metal. It is taking more metal and the yield will be slightly lower. So in case of a pressurized system, the system will always be full of liquid metal, full of liquid metal. In case of a unpressurized system, flow is not full. Yes, it is very, very important because in a pressurized system, the totally control is taken under a gate, under a gate. So we are going to be flowing a correct amount throughout the choke and the runner is filled and a gate is to be taking a very small amount of liquid. But in an unpressurized, the totally it is controlled at the choke only. So when the molten metal is started reducing at a gate area and as well as a runner area, there is a time is to be get taken at the choke area to get fill, to get fill. So it explains that it is not full. It explains that it is not full. What is going to be happen? So the next one, guidelines for the designing of a gating system. So the rise of the sprue fixes the flow rate. The size of the sprue fixes the flow rate. So depends on the size of the sprue only, the flow rate is to be depend. The amount of the molten metal that can be fed into the mold cavity in a given time period is limited by the size of the sprue. So it depends on the size of the sprue only, what is the pouring rate is to be taken, what is the solidification time is to be taken. So the sprue should be located at a certain distance from the gates so as to minimize the velocity of the molten metal at an ingate. So sprue must be not very large from the gating system. From the gating system, it must not be arranged in a very long distance. It must be arranged in a very short distance so that the velocity will be get minimized there. So whatever the molten metal you are going to pouring into the gates, it can be get minimized the velocity. So the sprue should be tapered by approximately 5% minimum to the avoid aspiration of the air and free fall of the metal. So sprue whatever is to be get taken, it is of a tapered shape only, approximately 5% minimum. It is not a totally tapered, it is only 5% minimum to avoid aspiration of the air. So in gates should be located in a thick regions. In-gates should be located in thick regions, not the thin regions. So locate the gates so as to minimize the erosion of the sand. So as to minimize the mold erosion of the sand, so gates are to be get arranged in a correct manner. So this may be achieved by orienting the gates in the direction of the natural flow paths. So this is to be get achieved when it is having a orientation of the gates when it is from the flow. So the multiple gating is frequently desirable. So multiple gating is frequently desirable. It is one of the advantage only, the multiple gating. So advantage of low pouring temperature, which improves the metallurgical structure of the casting. So when it is having a very medium amount of the pouring temperature, what it happens, a correct metallurgical bonding nature is to be get starts. A correct metallurgical bonding nature. If it is very fast rate, a good amount of sticky nature cannot be get starts. A good amount of bonding nature cannot be get occurred. When it is very low, a good amount of the bonding nature cannot be get occurred. So it must be minimum. So which improves the metallurgical structure of the casting. In addition, multiple gates helps to reduce the temperature gradients in the casting. Next. So the next slide is the difference between a pressurized gating system and a unpressurized gating system. So the pressurized gating system, it is in the order of 3 is to 2 is to 1. Unpressurized gating system 1 is to 3 is to 2. It is telling the order is in a pressurized, the gates is to get controlled. In unpressurized, the choke is to be get controlled. So it is to be arranged in this manner. It is maybe 3 is to 2 is to 1 or 2 is to 1 is to 2 is to 2 is to 1 at pressurized. It can be unpressurized 1 is to 3 is to 2 or 1 is to 2 is to 2. Any of the, it depends, it is more. So air aspiration effect is minimum in a pressurized. But whereas in unpressurized, air aspiration effect is more. So volume flow of liquid from every ingate is almost equal. It is almost equal from each and every ingate. But in an unpressurized gating system, it is not equal because the whatever the first ingate, it is completed. The runner is to be get complete, but the choke cannot be get filled. It is not filling because it is totally controlled by choke only. So volume of the flow of liquid from every ingate is different. So they are smaller in volume for a given flow rate of metal. Therefore, the casting yield is higher. So they are smaller in volume for a given flow of rate of a metal. Therefore, a casting yield is higher. So they are a larger in volume because they involve larger runners and kits as compared to the pressurized system, and thus the casting yield is reduced. So compared to the pressurized system, here whatever you are using a runners and a gate, it is more. It is very large amount of area. The area is very large compared to the pressurized gating system. Therefore, thus the casting yield is reduced. So the velocity is high under a pressurized system. Severe turbulence may occur at the corners. So in a pressurized gating system, the velocity is very high. It is very high. Therefore, the severe turbulence may occur in a but in an unpressurized gating system, the velocity is low and the turbulence is reduced. The velocity is low and turbulence is reduced. So this is the main difference between a pressurized gating system and unpressurized gating system. Right. So the first thing is, what is a gate? What is a gating system? How it is to be get arranged? What is the main use of a gating system? What is the importance of a gating system? So it must be very smooth. It must be having a uniform shape. It must be not having any in different shapes. In different shapes, it must be having a very uniform shape. It must be very smooth so that a correct molten metal can be get poured into the cavity. So these are the elements. One is a sprue, pouring cap, sprue base, casting, runner, gates, in-gates, and a runner extension. So what is the definition of each and every element? So what is the function of a gating system? So when it is having a very small type of gating system, what are the different types of defects have to be getting? So what is the time to be get solidify? What is the amount, what is the proper temperature is to be get taken to pour the molten metal? So what are the different effects? Oxidation of the metal, cold shuts, mold erosion, shrinkages, porosity, and emissions. So these are the different defects are to be get occurred due to the improper designing of a gating system. When the gating system is not designed in an improper way, it is to be get starts. So and another type is when there is a heavy flow and when there is a very low flow of molten metal into the mold cavity, there is some type of defects are to be get occurred. So these are the types of gates. One has a horizontal gating system, the other is a vertical gating system. So top gating system, bottom gating system, and a parting line gating system in a horizontal gating system. So most of the thing, this is the thing which is to be get used. So in a topping gating system, to the mold cavity, the gating is to be get arranged. It is to be get arranged. So bottom gating system to the mold cavity, the gate is arranged to the bottom, and a mold parting line gating system to the drag. We are going to be arrange the gate, not for this cope. We are going to be arrange the gate over to the drag only. So what is the pouring time? So pouring time, it depends on what is the quantity of the molten metal is to be get carried over to the mold cavity and how much amount is to be get taken. So what is the pouring time is to be get, or what is the time to be get taken over to the pour, right? So it depends on the size of the cavity. It depends on the size and the molten metal. What is the type of molten metal? It depends on the shape of the thing also. So it depends on the sprue, runner, and each and everything, and it also depends on the pressurized system and as well as an unpressurized system also. So when the different types of rating systems are to be used, what type of defects you are going to be getting? When it is very fast, you are getting a rough surface, mold erosion, excessive shrinkage. When it is very low, you are getting a cold shut and a misruns. So gating ratio is designed by three parts. One is a choke area, runner area, and a in-gate area. So under the gating ratio, it is explained in two types. One is pressurized system, the second one is a unpressurized system. So pressurized system is used for magnesium alloys. It is a reactive metals. It is used for reactive metals. Whereas unpressurized gating, it is used for brass, steel, and aluminium. So in a pressurized system, it is arranged in a manner that it is totally control over the gate only. It is totally control over in gate. So it is arranged 1:2:1. So in gate must be the size of in gate must be very low compared to the other part. So whereas unpressurized, it is totally controlled over a choke area. It is totally controlled over a choke area. So it is nothing but 1:2:2 or 1:3:3 or 1:1:3. So pressurized system is referred as a gate control system and unpressurized choke control system. So it depends on the design of the ratio, the velocity is to be get taken. So when it is a high velocity, it is going to be getting a high turbulence. When it is low velocity, it is getting a low turbulence. And there must not be very long distance between a sprue and as well as a gate. When it is a very long distance, the velocity is very less. So to minimize the velocity, what is going to be taken? The distance between a sprue and a gate must be very less, right? When it is very large, the number of defects is to be get start occurs. So what is the guidelines for the designing of a gating system. So what is a pressurized gating system? What is an unpressurized gating system? So the outcomes to reduce the warpage proper gating system plays a very major role. So optimized gating system improving the casting quality and increasing the casting yield. And optimum gating position leads to sound casting. Proper gating framework are essential to secure the quality of the casting. So this explains that what is meant by a gating system. Okay. So in your third unit, selection of the casting process. So metal casting means the first thing, what is the type of sand is to be get taken, what is the type of patterns, the mouldic cavities, the gates, sprues, runners, furnaces which are to get used to mold the metal, what is the types of solidification, what is the type of tolerances are to be get taken. So what after completion of the casting, how it is to be get modified, what are the different operations can be get done. So these all comes under the metal casting. So in this class we have learned about what is meant by a gating system. Okay. So in the next class we will learn about what is meant by in the next class we will see about what is meant by design considerations for the casting. We will see that what are the design considerations for the casting. So how it is to be get designed. So what is metal casting, design and materials and economics. So how much cost is to be get taken. So how is it is designed, what is the materials. So this we will learn in the next class. So what are the different defects are to be get occurred, what is the design considerations. So I think we have learned in a first unit. So which type of casting is to be get accepted, which type of casting is not to be get accepted. So these are the points which we will learn in the next class. Okay, students. So any doubt?